Hello, Miss Pneumatic here. Today, we're going to learn about air filters that help purify compressed air. So what is a filter? The dictionary definition of filters is a device that filters out foreign particles in liquids or gases. An air filter is a device that filters out foreign particles in the air. There are millions of particles that may not be visible to the human eye, such as oils, moisture, dust, etc., in the air that we breathe. An air compressor gathers this air to create compressed air. And the compressed air is later injected into drive devices to be used as working fluid. Then what happens when unpurified compressed air goes into a drive device? The particles can cause a number of problems with the operation of the device. Therefore, it is necessary to continuously filter out particles and purify the air through the air filter. We will now take a look at why air filters have to be used and what problems can occur by not using it. Also, we will learn about the working principle on how it purifies the air. Why is it absolutely necessary to use air filters? You might assume that there wouldn't be any big problems just using it as it is. But as I mentioned earlier, there are millions of particles in the air. They include oil, moisture, dust, carbon, and even heavy metals. If compressed air containing such particles is used without purifying, then it can amass in the drive device, which will contaminate the product and cause defective operation. In the long run, it will even shorten the life of the product. Using a filter can prevent such problems from occurring. By removing the particles inside the compressed air, it can prevent malfunctions caused by foreign particles, and in the long run, it will lengthen the product life, thus saving on maintenance costs and costs for replacing the product. Let's take a look at how the air filter purifies the air. We will check it out in detail using an internal structural map on the process of compressed air going in and out of the filter. First, compressed air comes into the air filter through the inlet. Next, the compressed air comes into contact with a deflector. The deflector looks similar to an electric fan, and it allows the compressed air to rotate quickly by being evenly distributed along the spiral face. The compressed air swirls quickly due to the deflector and drops down to the bottom of the filter. At this time, particles such as dust, moisture, and oils that are heavy and have larger particles hit the walls due to the centrifugal force and drops down and gathers at the bottom of the bowl. And the air that has very small particles and is lightweight exits after passing the filter element in the middle of the filter. Here, the baffle stops the particles collected on the bottom of the bowl from exiting through the outlet due to the strong winds of the compressed air. After filtering several times, particles pile up on the bottom of the bowl. It can be discharged to the outside through the drain on the bottom of the filter. There are two ways. The automatic drain type automatically discharges the particles when they pile up to a certain amount, and the manual drain type discharges the particles by turning or pressing down on a hand valve. If the filter operation rate is high, then it will be more convenient to discharge regularly with the automatic type. And if the operation rate is low, you should choose the manual type and discharge as needed. Lastly, we will take a look at the filtration rate of filters. The particle filtration rate of filter elements that remove foreign particles are expressed in units called microns. This is a very tiny size where 1 micron equals 1/1000th of 1 millimeter. When purchasing filters, the micron unit expressed in the product specifications means that the smaller the number, the tinier the particle that can be filtered out. Check the filter selection guide table for reference when purchasing products of different brands. And you will see that the usage environment changes depending on the micron size of the filtration rate. I summarized the filtration rate of some of the filters of KCC and what equipment they are normally used in. KAF models with a filtration rate of 5 microns are commonly used in general pneumatic equipment such as general industrial automation devices, air vise, chucks, etc. On the other hand, KFU models with very high filtration rates of 0.01 microns are used for precision measuring instruments and clean room equipment that require a high level of cleanliness. So, before buying a filter, you should check the filtration rate written on the product specifications first to purchase the product that is best for your usage environment. Today we learned about air filters. How did you like it? I hope it was helpful for people who knew that filters existed but were curious about how exactly the purification works. If this was helpful, please click on the like and subscribe button. See you again later. Bye!
Miss Pneumatic Channel is working together with KCC Precision.